Hello guys, this is Kene, and today we'll be looking at a problem that would be using Python to solve, and that has to do with number bases. So the question is the problem is convert a number in a base not exceeding 16. So it could be base 10, base 11, base 12, the number in base 13, the number in base 14, the number in base 15. Or 16, but not beyond that, right? And that number should be expressed as a base 10 number. That's what we're asked to do. So I have some examples here. 254 base 6 to base 10. And then 62e base 16 to base 10. Now, base 16, a number in base 16 is commonly called a hexadecimal number, and a number in base 10 expressed in base 10 is a decimal number. I hope you get that, guys. Now, if it's a number in base 2, then we know that it's a binary number. So those are like the three most commonly used types of numbers in terms of the base. Okay, so computers count in zeros and ones. So we say, okay, the numbers are in base 2. So computers understand base 2 numbers, and we humans, it's for we human beings, it's easy for us to count in base 10. So we get to 9 and then 10. I know how we would say, okay, leave the 1 and leave the 0 and carry the 1 to the tens, part. So all that has to do with counting. So guys, let's see. So if I had 254 base 6 to base 10, how do I, get that to be in base 10? Actually, there are three things that we must consider. The first is the digits. The digits there. So this is digit 2, this is digit 5, and this is digit 4. So the digits are considered like separately, the digits that constitute the number. Then the second thing that we must consider is the base, the existing base, which is like 6, base 6. So that's the existing base for this number. That's the second thing. And then the third thing that we must consider when converting a number in some base to its base 10 equivalent is, guys, please don't forget, the index of the number, the position of that digit. So the digit itself, say 4, for example, and its index. Now, we begin indexing. So if I had 254, I would begin the indexing, right, from 0. So this will be like index 2, index 1, and index 0. So digit 4 at index 0, digit 5 at index 1, digit 2 at index 2, and the base is 6. Do you guys get? Now, normally computers will start counting from 0. So it should be, if the computer counts, it goes from 0, 1, 2, 0, 1, 2, 3. So the first number is indexed 0, that index 0. But for our purpose here, it is the last number that is indexed 0. That's what I'm going to adopt here to get the solution to my question. Right. So using those three things now, guys, we'll get the digits, and we multiply the digits by the base raised to the power of the index of that digit, taking the last position to be 0. So if I had 2, then 5, for 254, and this is 4. So these are the digits, right, that constitute the number. I am to multiply, sorry, guys, I will multiply, I'll multiply that digit by the base. So I should put that so that that is done by the base, right, raised to the power of the index. Guys, please, we begin indexing from 0 at the back. So 0, index 1, and index 2. So 6 raised to the power of 2. Then 5 multiplied by, the 6 there is like a constant value. That's the base. 6 raised to the power of 1, which is the index. And then the beginning index from the back, from the right, we should now have 6 raised to the power of 0. So 0 is the index from the rear, taking it from the back. Okay, so guys, let's now evaluate each of these expressions here. 6 raised to the power of 2 is 36. Multiply that by 2. 36 divided by 36 times 2, 72. Then 6 raised to the power of 1 is 6, and 6 multiplied by 5 is 30. 6 raised to the power of 0. Whatever we have as a digit raised to the power of 0 will return 1. So x raised to the power of 0 is 1. 6 raised to the power of 0 is 1. 1 times 4, that gives us 4. So I'll add the numbers collected. 72, 30, that's 72 plus 30, 102. 102 plus 4, the final result gives us 100. And okay, the final result is 106. All right, so I hope that's clear, guys. That's just how we go about it. So 254 base 6 to base 10 is 106. Right, then let's look at the other one there, 62E. Now, I want us to take note of the E, the letter there. We are counting in 16s, right? And let's take base 10 decimals. We can't really have 10. We get 10, then we need a single digit. We take the one to the right, that's 0. And we transfer, that's like the unit. Then the 1 goes to, the tens position. How, in primary school, we have 100 tens and units. So once I get 10, that means that actually it's no longer units, it becomes 110. That shows we're counting in 10, right? So in this case, if I'm counting in 16, then I can't have like a 16. So once I get to 15, it moves to 16. So the unit is everything just before 16. So if I had this 1, now I'm giving us base 10 numbers, decimals. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then, now guys, 10, 11, 12, 13, 14, 15. Now, I'm getting to 15 because I want to compare. I want to do some comparison. You will see that when I get the equivalent in base 16, reaching 10, when I get to 10, there will be a difference. That difference is the use of letters to represent values, okay? Number values. So if I had 1, yeah, no problem. 2, that's not up to 16. 3, 4, 5, 6, 7, 8, 9. Now, 9. I can't have a 10, right? So I need to bring in letters. So beginning from 10, I will take A. So A is like the equivalent of 10 in hexadecimal numbers. So I will have A here, then B, C, D, E. So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Now, because this is base 16, I won't get to the 16 itself. Right. So, guys, we are going to use this table to do our computation. So I'm going to take 62E, right? And we'll perform this kind of operation. So for every digit, I will multiply it by the base raised to the power of the index of that digit, taking the beginning index from the back, which is index 0. So I would say 6 multiplied by, now it is base 16 raised to the power of, we'll come to that. So let's just leave that for now. Then 2 multiplied by 16 raised to the power of, we'll come back to that later. And then E multiplied by 16 raised to the power. Now, this E is the number at index 0. So I would say 16 raised to the power of 0. Then this should be 16 raised to the power of 1. So I'll just increase by 1 every time. Then this is 16 raised to the power of 2. Right. So guys, 16 raised to the power of 2. Let me use a calculator for that. That is 16 multiplied by 16. 256 multiplied by 6. Multiplied by 6. So that's 1,536. Okay, so that's it. 1,536. And here, 16 raised to the power of 1 is 16 multiplied by 2, 32. And here, 16 raised to the power of 0. Remember, guys, a value I have raised, or a variable raised to the power of 0 is 1. Okay. Now, I have put E multiplied by this expression here. The question is, okay. So now what's E? We need to use this table to get the equivalent of E, right, in decimal. And if you guys recall, if F is 14, E will be if F is 15, E will be 14, right? Because guys, let's recall, I need the E. So E is 14. So instead of having this E here, then I'm going to put 14 because I need a number to be able to carry out, arithmetic operation. So 16 raised to the power of 0 is 16. Then, 16 raised to the power of 0 is 1, rather. Remember, raised to the power of 0 gives 1. So 1 times 14, that's 14. Then I add up the figures obtained. 1536 plus 32. So I'll just use a calculator. 1536 plus 32, and then plus 14. Oh, sorry guys, an error there. 1536 plus 32 plus 14. So that's 1582. All right, so guys, 62E base 16, of course, will be 1582 that should give us 1582. So 1582 in base 10. So that's how we do the conversion, getting a number in any base to base 10. Right. Now, what about the code part of it? How do I do this same thing, but this time using Python language? So this is the thinking. Since I have 3 digits, for example, in 254, I'll use a loop. Already, I'll get the number of digits that constitute the number. So 3 digits constitute the number 254. So I'll take each of the numbers, like from the beginning this time in my loop. So 2, then I'll get the base, which is like constant, and the index, that is the count of the loop at that point. So when it comes the first time, for example, this should be the highest in terms of the count. Since I have 3 digits, and the computer is going to start counting from 0, right? So the maximum count there will be 2. For 3 digits, the count will be 2. The count represents the index. So what I will do is that I'll take the largest count there, which is 2. So I will say 6 raised to the power of this maximum count multiplied by the digits at that index, at this count index. Do you understand? So that's what I'm going to do. And when I'm done with that digit 2 in this case, I'll use my code, the Python code, to cut it out. So the 2 will be cut out such that what is left is 54. And the same thing is done with the first digit now this time. So when I cut 2 off, the first digit now becomes 5. Then I would now get the count at that point. So the next lower count after 2 coming down will be 5. So that base raised to the power of that count, then multiplied by the digit there, the first digit, which is now 5. When I'm done with the 5, I'll cut it out so that I have 4 left. Now, the count at that point will now be 0. You keep decreasing, the count keeps decreasing. So 6, which is the base, raised to the power of the count there, which is 0 at this point, multiplied by the digits at that index, the count index. So when all that is retrieved, I will add the results to get the final answer. So that's what we're going to implement using Python code. All right. So guys, let's get on with it. Okay. So let me just get some variables. So I'll say my input, and that should be 254. Then I will create I need to know the count, the number of characters that constitute the input, in this case, which is 254. I assume that this is the figure imputed by the user, even though that's not what is actually happening. But let's just take it as such, for our purpose. So I'll get the count or the length, number of characters. That would just require using the len method and give it my in variable there. So that counts it. However, guys, you know that the len method, if you've been looking at my videos, you must have heard me say that the len method gives us the actual number of characters. So if there are 3 digits, len method returns 3. If there are 3 characters, len method returns 3. But when I'm counting, I would count from 0, like as a computer. So to get to 3, I would have gone from 0 to 2. I will get the third element there. So you see that even though count returns the actual number of characters, I will do the counting from 0. So that means there's a difference of 1. There's a difference of 1 between the actual number of characters and the count value beginning from 0. So that's why we need to do a -1 because the computer is going to count from 0. Right. So, guys, next I'm going to do is to create a variable that will hold the answer, that will store the answer. So, 72 will be obtained in the first iteration. There has to be a variable to hold it so that, when the computation is done in the second iteration, that number that is obtained, which is 30, will be added to that which was held in the variable that I'm going to create, which is, at that point 72. So 30 plus 72, then it's stored again in that variable, cumulative addition operator that we talked about. Then, the new value is stored in that answer variable. Then in the third iteration, we'll get 4 following the computation. So that 4 will be added to the value of the ans, and the new answer is stored in the ans variable. So we need that variable, and I'm just going to call it ans variable, and I initialize it to 0 at the beginning. Okay, so let's create a while loop. Now, while the length of my imp is greater than 0. So long as there's something a digit to use, just keep looping, right? Okay, so I don't know why this is showing up as an error. Let's see. Okay, so guys, please, I need to make this a string. I need to make this a string, please. I'm going to get the number, but just put quotes to make it a string. If I were using the input method, what is returned will automatically be a string. So there won't be any need to put the quotes. But in this case, I am doing it, statically. So that requires using quotes. Then I'll come here. Now, while the length of my imp is greater than 0, what should happen? The first thing I want, guys, is to grab the first character in that number. What's the first character? And how do I get the first character in a string? We use the square brackets, just this anyway. So when I do it, you can see for yourself. So I'll just store it in a variable called 1 character, just 1. So that should give me, using my imp, not the count of my imp this time, just the input itself, my imp, and the first character will be that number or the digit at the character at index 0. The first is indexed 0 in Python. So that's how I've grabbed the first. So what we're doing here is that at this point, I'm taking 2. So this is 2 here that will be, obtained and stored in this one car. Right. So having got the first character now, I'm going to ask myself, there's something that I'm going to say here, guys. We created this, hexadecimal. So I'm supposed to perform mathematical operations on numbers. So if I have A and I want to do something mathematical on A, then I need it to be converted to 10. I need it to actually grab 10 if it is A that the user inputs or that I actually inputted as the programmer here. So just like I have E here, I need something that will actually tell me that E there stands for 14. So I'll go back here and create a dictionary. So there's a relationship there, key value pairs. So the key will be the key there will be the the letter, and the value will be the number. So the key will be 10, for example, and the value, I mean, the key will be A. The key will be A, and the value will be 10. Key will be B, and the value will be 11. So that's the kind of thing I want to create, a container to hold those key value pairs. That's a dictionary, in Python. So I'm just going to say my dict. So I have, in this case, this should be A, and that has a value of 10. B, it's a string. The key is a string. So please put the B and the A and the C in quotes. Colon, the value will be 11. Then this is C, and the value is 12. Let me just get on with this. Okay, so key value pairs there in a dictionary. Now, guys, I'm going to check if the computer grabs, or Python grabs this first digit, grabs this digit anyway at this position, right? The first position. If it is a letter, then don't give me the letter, give me its decimal equivalent. So I'm going to use my dict. I know if you want to grab a value from a dictionary, you simply, guys, don't forget, go back to the lesson. Watch the other videos, and you would see that I used like when we looked at converting decimals to Roman numerals, I used dictionaries there. So you can watch that video. So to grab a value from a dictionary, I'll simply say my dict and the value, I mean the key for that value, just like this. So this here, my dict in brackets A will be 10. That's what will be returned, 10. That's how we grab values from dictionaries using keys. Okay, so here now, I'm going to ask, I'm going to check, using an if block. If that letter now at position 0, the first letter, I mean the first position there rather, is a letter, then please give me the number equivalent. Right, so let's see, using an if clause there, if, I'm going to use not. If not, now, guys, one car, if it is a digit, if it is a number, then if it is not a number, if it is not a number, the computer should do this thing only if what I get at position 0 is not a number. In other words, if it is not a number, then we suppose that it is a letter, right? And if it is a letter, then grab me the value of that letter from the dictionary. So I'm going to now store it in another variable. So I'm going to create a variable here, stored value, or let me just say val, val, and that will be the dictionary, my dict. Okay, at the position. So the position there is kind of the index, I mean the key rather, which is A. So if I have A in this dictionary as a key, it will return 10 as the value. So that's the kind of thing I'm talking about. So I'm just going to now say that one car is the key. This is the letter. Let's say this is the letter A. And so if A is placed here in this dictionary, A will return 10 because I need to use the number, not the letter, for mathematical operation. All right, else, I'm just going to put else to show us the use of the if else block. So val should be what? The val should be simply give us one car. That means it is already a number. It's a number already. So I don't need to go to the dictionary to get the number equivalent of the letter because it's already a number. That's why nothing is going to happen here. Right. So now having, make sure that I have numbers, even though a letter was inputted, it's being converted to a number right here. I'm now going to make use of that number. Okay. Now cut that number out from the constituent of the input or the number we are trying to convert to base 10. So I'm going to, and how do we remove the first character of a number? I mean, of a string. How do I remove the first character of a string in Python? Guys, watch. So I'm going to now make the new value of my imp. The new value of my imp will now be what? My imp with this. That is, I want the system to return everything apart from the first character. Do you guys understand? So I will put a colon here and a 1. So it actually cuts off 1 and every other thing is returned. I hope you guys understand. Okay, so that done now, I have what is returned when the first character has been removed. But I need to do something with that first character before removing it. So that will take me to this point before the removal. What should I do with that first character? I will take that first character. Remember, guys, this thing here. So let's say this is the first character. I will take that first character, then do this exponent operation here, right? 6 raised to the power of the index. That's the same thing I'm going to do here. So I will have the first character, which is 1 car. And remember that 1 car needs to be explicitly set as an integer. So I'm going to make sure that it is a number, like in the actual sense of a number, not a string. So 1 can get it to be an integer, right? Multiply that by, guys, what's the base? The base is, I need to, okay, set the base outside here. So I'm just going to say the base, T base. In this case, it is 6, base 6. I want to set that as a variable. So T base multiplied by, raised to the power. In this case, I'll use the exponent. Remember, 2 stars. So that means, like if I have A with 2 asterisks and B, then it will be A raised to the power of B. So T base raised to the power of, and what's the position? What's the position here? Again, now, guys, I need to create a variable that will keep track of the position. Okay, now that variable is number of characters. That's what it is here. So let's say I have 3 characters, then the maximum count will be 2. It goes from 0, 1, 2. I've covered all 3 characters. So that's what I'm going to give there as the operand. Number number of characters. Guys, I've used this first character with the exponent. Now I need to save it, store it in a variable. It will be held there until it's time to do this operation using a new digit, right? So again, a new value will result from this operation, and that new value will be added to the previously held value. And remember that we created a variable to hold, the result of this. I lost my connection there for a moment, so I just to share my screen. Okay, so as I was saying, I'm going to store the result of this entire operation to the ans variable. And I set the variable ans to be 0. So there's cumulative addition. Whatever was the last value of ans, add the result of this operation, this entire operation, to that value, and restore the as in what I get here and added to the previous value of ans, store that outcome, that output in the same ans variable. So I'll take the value of ans, add something to it, and store what the new value in the same ans. So to achieve that, I'm going to use that relative addition operator there. So that's just something like this, all right? Then finally, okay, just before then, guys, I must make sure that I remove that digit I've just used, the first digit, so that there's a new first digit. So this removes the first digit, just like this. Then finally, I will now reduce, because the index has to keep reducing. So this is like index 2, which is number of cars. Then when I remove 1 from the number of cars, the index will be reduced by 1, right? So I need to reduce that. So the new value of number of characters will be the former value of number of characters, or rather the current number representing number of characters minus 1. But to make it shorter, remember, guys, we remember this when we looked at operators. So this will be minus 1, just 1. So for every current value of number of characters, remove 1 and store the result in the same variable, number of characters. Okay, so I will now output the eventual value of ans. So print, I'll now print ans. Okay, so guys, let me comment this stuff I use for explanation. I'll just use triple quotes. Okay, all right. So if all goes as planned, then we should have the right answer. So remember, guys, that's 254. When we did it together here, we got 106. So let's see if that's what we're going to get. 106. Beautiful. So that's how we convert a number in some base not exceeding base 16 to its base 10 equivalent. Let's even try 62e. So this will be changed. Let me change this to 62e. 62e, and run the program. Okay, so what does this say here? Invalid literal for int with base 10 e. Okay, so if not 1 car is digits. So this here saying if this character is not a digit, if this character is not a digit, then what should be returned? So, oh, sorry guys. I'm going to use val as the character we are using at that point. Do you guys get? So it's actually going to be val. This should be val here. I don't know why that didn't occur to me. So you know, that character, if it's a letter, then grab the number equivalent from the dictionary. But if it is not a letter, if it's already a number, then just save that number in val. That's just all we are saying. Then use the val as the digit. So let's see again if all goes well. 242. I don't think that is correct. Let me try 254 again. Try 254. 254. Oh, sorry guys, that's correct. I ought to change the base. So this should be base 16. Since I'm using 62E, 62E base 16, what will be the decimal equivalent? 1582, and that's what we got here, guys. Remember, 1582. Okay, so guys, that's it. I hope we learned something. You shouldn't get confused here. Just can watch the video again to make sure you understand the steps and the operations performed, right? I'll see you guys in the next video. Do have a great day. Bye.